So what I'm going to do is I'm going to create a blueprint class, and I'm going to make this, we could make it actor or we could make it pawn. I'm going to go ahead and just make it a pawn. And so what the way the hierarchy works is you have, that's weird, you have actor, pawns are types of actor, and then what we've done is we're going to create two classes below pawn for towers and for enemies. And then below towers, well, we'll just create one today, but you could imagine having multiples. Okay, so we'll say there's tower type A, tower type B, etc. And then similarly with enemies, we could have multiple kinds of enemies. We could also have, for example, categories of enemies, like in some tower defense games, there's flying enemies that only certain towers can shoot versus other enemies that, right? So there's subcategories that perhaps are within it. But yeah, so I want to concentrate on the tower part for right now. The benefit of doing this in sort of a hierarchy is it means that anything that the tower class has as part of it, all the children get too, okay? So, for example, the function to select which target, right, that the tower is going to shoot at is something that all towers need, not just specific kinds. And so what we can do is if we write this function, we'll put it in the class rather than in the individual towers, and that means that all the towers can access it because it's in a parent of them. The other thing that this means is you don't have to cast to get to it because you're already there, right? A tower of type A is a tower, and so anything that comes with the tower A inherits. Okay, does that make sense? Okay, so I've got the tower parent class, and then I'm going to create a child blueprint of this, which will be, say, tower type A, whatever. Okay. Now, in the parent class, what things do I want? Well, in terms of visuals, probably don't need anything, right? Because this isn't actually a tower, it's just sort of a generic, like, placeholder category thing, okay? But what things do all towers have in common? Yeah, the function, which we'll create. Okay, but also things like how much the thing costs, maybe how much damage it does, maybe what its fire rate is, some variables along those lines. Okay, so let me just make a few of those right now. So we'll make a cost variable. We'll make a fire rate variable, and we'll make a damage variable. All right, what variable type should this be? Cost should be a what? What type? Either a float or I'm going to go with an integer just so that the price is whole number stuff. Fire rate should be a float, and damage should also be a float. Okay, good? Maybe we'd want the cost to be a float because you could have, like, say, partial coin or something, but I'll just leave it as an integer for right now. Okay, great. So, compile and save. And then, if I make a tower type A, right, it doesn't look like the variables are there. Okay, but if I place a tower type A actor in the world, then, hold on. I think I forgot to do one thing. Oh, I need to make these instance editable. because that means that different instances could have different properties, right? Oh, and then I need to recompile and save. Okay. So if I, oops, not that one. This one, right? Then I have cost, fire rate, and damage for that specific tower, okay? And if I had multiple, then I could set what they were for those, for multiple, okay? Okay, good. Now, as for the function, what we need to do is we need to make that function. So I'll create a function, and which way are we going to go with this, right? What were the three options that made sense in terms of shooting? Weakest, strongest, closest, maybe furthest. Let me just do weakest for sake of example, okay? Honestly, doesn't really matter. Some tower defense games actually have options where you can set which one it's going to be, but weakest probably makes most sense. So I'm going to call this function get weakest, okay? Now, this function, and this is something that we haven't needed before, has inputs and it also has outputs, okay? So what is going to go into the function and what's going to come out of the function? A list of actors that are going to be overlapping some sort of collision volume, okay? And then what's going to come out is a single actor reference that is pointing at the specific actor that's weakest, okay? So my inputs are going to be an array of enemies, okay? And that's going to be an object type, actor, object reference, okay? And it's going to be an array of them, meaning that it could be like, there could be 50 enemies within a collision volume, and that list of 50 enemies would get passed to my function, and my function should spit out the one of them that's the weakest. Okay, so good with that? All right, so then what comes out of the function is not an array, but rather a single actor reference, okay? So array comes in, single guy goes out. Make sense? Okay, so let me break this, and then let me just save it. Okay, now, things are going to come in, but these things need to have health. Have I defined the enemy class yet? No, so I need to make that. All right, so let me back up here, close this for now. And I'm going to make a blueprint class of class pawn. Okay, and I'm going to make an enemy parent class. And then within that, I'll make enemy type A. Okay, and then I could have enemy type B and C and so on, whatever. Okay, now within the enemy parent class, what variables should an enemy have? Well, it should have, amongst other things, health. What data type? Integer or float? Probably float makes more sense here, okay? Again, I want this instance editable. And what do I want its default value to be? I'll just say 100, okay? Whatever. Okay, now, what this means, though, is that enemy type A is an instance of an enemy. So if I plop one of these in, which right now doesn't have any corporeal existence, notice it has a health variable, right? And that makes sense, okay? So it inherited that value from the parent class, okay? But in particular, it has a health variable, and that's what our function is going to need to look at in order to determine who's the weakest thing, right? There's got to be something to examine. Okay, so let's go back into the parent class. All right, so remember, what's coming in is a list of actors. What's going out is a single actor. Sorry, I'm trying to lower the glare a little bit. Okay, so how is this algorithm going to work? Well, let's say that I have a list of 50 things. How do I go through that and find the one that has the smallest amount of health? Right? Like, talk us through it, like in words. What would I do? Yeah, we're definitely going to need a loop. Okay, good. Okay, so what do you do on each step of that loop? Yeah?
So you take like the original one and compare it to like number one, and then if it's lower than, you would use that one, and if the second one's higher, then you would just keep the first one.
Right. So what you do depends on which thing in the array you're looking at. If it's the first thing in the array, you don't have anything to compare to yet. So the first thing you come across is automatically the weakest that you've looked at so far. The second thing, you then say, oh, how does that compare to my weakest? Is it weaker? If so, do one thing. If not, just move on to the next item. Okay? So what we're basically doing is a searching algorithm. We have to go through the entire loop, the entire array, all the elements of it, because how do we know that the dude at the end isn't the weakest? We don't, right? We don't know that they're going to be in any given order when they come in. Okay, so what I need to do is so let me scooch this here. The magic word was loop, right? And we're going to do a for each loop, because a for each loop iterates over the contents of an array. Well, that's perfect, because what are we passing our function? An array. Okay, so that's good, right? And what it's going to do is go through one by one each element of this array and do something. Okay, so the array goes here. Okay? Now, here's one other thing that we're going to need to do. We need to make a temporary variable, well, actually two of them, that's going to store who is the current weakest object that we've looked at. Okay? And that which weakest object we've looked at is going to update as we go through the array. Okay? So we need to make a temporary variable that really this is only used inside this function. It's never used anywhere else. Okay, and look over there on the left on the Components tab and the Blueprint, My Blueprint tab. What all do you see? We've got variables, but what's down there at the bottom? Local variables. So a local variable is a variable that only exists inside this function. It can't be cached and accessed from anywhere else. Okay, but that's perfect because that's what we need, right? We need two variables to hold which dude have we found so far that's the weakest, and what was its weakest health. Okay, so we need to make two local variables. One of them is going to be a health number, and the other is going to be an actor reference. Okay, so what we'll do is we'll call this temp health and temp enemy. All right, what data type should these guys be? Health is what kind of variable? What data type? We made it a float, so it should be a float. Okay. And what's temp enemy? That's an actor reference. Okay? All right, does that make sense? All right, so we've got an array. We come to the very first thing in the array. Is he the weakest thing we've come across so far? Yeah, because we haven't looked at anything else yet. So automatically, the first thing in my array is the weakest that I've examined so far. So I need to make the health the health of the first thing, the temp health, the health of the first thing, and the temp enemy, the reference to the first thing. Okay, so here's where it's going to start to get fun. I just said if it's the first item in the loop. Okay? Well, you'll notice there's two things here, array element and array index. Index would be something, an integer that counts which item are we in our list. So if we've got 50 things, are we on number 7, number 30, whatever, right? Array element is the actual object that we're looking at, okay, which is an actor reference in this case. All right, so pop quiz. In C++, which is what Unreal is built on, the first element in an array, what is its index? You two keep your mouths shut. This is pop quiz for everybody else. The first element of an array, its index is it's 0. Okay? Where do we start counting in computer science? 0. Okay? So the first element is really the 0th element. Okay? So if I want to know if I'm looking at the first element, I need to know, is my array index equal to what? 0. Okay? So I'm going to do equals here, and I want integer equals. Okay? And I'm going to compare against 0. And then I'm going to go into a branch. Okay? And, okay, so this branch, I either am looking at the first dude or I'm not looking at the first dude. What do we do if we're looking at the first dude? So that's the true case. What do we do? Oh, we are not even close to talking about creating the projectile. We're just trying to figure out who's the weakest item to shoot at. We'll figure out how to shoot later. Yeah.
So if it's true, we set the new minimum weakness.
Yeah, if it's true, that means we are looking at the very first thing in the array. So if we're looking at the first thing in the array, who's the weakest thing? Automatically, the first thing in the array. So what I need to do is set the values of my two local variables to the first thing in the array's health and the first thing in the array's reference. Okay, does that make sense? Okay, so we need to do that. All right, so what this means is I need two of these, right, to set the health and to set the reference. Okay, and I'm going to do the reference first for reasons that'll become clear in a moment. Well, what's the first dude in the array? That's the array element. So I can connect this to here, and then because this is starting to look a little messy, I can, if you double click on a wire, you can, oops. You can, damn it. There we go. Damn it, Bobby. Yeah, King of the Hill. Okay. Nobody laughed, though. Okay, so we got that. So we need to set the temp enemy to that reference. And then what else do we need to do? We need to set the health. But who owns the health variable? An enemy. Which blueprint are we in? A tower. So how do I get to an enemy variable if I'm in not the enemy? I have to cast. Okay? So I need to cast to enemy parent class, right? Because that's what an enemy is. Okay. And then what object am I casting to? This one, the one that I'm looking at. Okay. Then as the parent class, what do I need to get? I need to get health. So this is the health of the particular enemy I'm looking at, and I need to set that to the temp health variable. Oops. And then connect this to here, and we should be good. Okay, so let's make sure that that makes sense, right? Why do we have to cast? Because the health that we need to look at is sitting where? It's inside an enemy. We're not inside the enemy. We're inside the tower, two different objects. Okay, does that make sense? Okay, so this was the very first item in the array. We now have to do, what do we do for the second and any subsequent items in the array? Go back to the false. That's where that's going to come off of, because, all right, so the false case is here. No, I am not looking at the first. I'm looking at the second or subsequent item. Okay, so for all other items, what do I need to do? I get to the second one, and then what am I going to say? I've got a temp health over there, and it's 50. And I've got the health of the second dude, and it's whatever. What happens if the health of the second guy is lower than the temp health? What should I do? Set the temp health to the health of the second guy, and set the temp enemy to the reference to the second guy. Otherwise, what should I do? Leave it at what it was. Okay, so do nothing, right? Okay, so this means we need to go into a comparison, another branch. Okay, so false. Sorry, the computer's being really ornery this morning. Why are you? Come on. Okay, so how do we get to the health of something? We need to cast to the enemy parent class. Okay, and what are we casting to? We're casting to this object. Okay, and then as the enemy parent class, what are we getting? We're getting the health. Oops. Okay, and then lastly, I need to do a comparison here. Okay, so this health number, I need to compare to my temp health. So what kind of comparison do I want to use? What math? A less than, right? Because I want to see, is the second dude's health less than what my current minimum is? Okay, so I need to do a less than. I could use greater than, but same thing. Okay, so I want to do float less than float, and what's the float I'm going to compare against? The first one is the health of the item I'm considering, but what's the other one? The temp health. Okay, so I just need to get temp health, and this dude's going to just slot right in here. Okay, so what comes out of this comparison? A true false, which means what is it going to pipe into? A what? A branch. Okay, because branch is what we call if-then in Unreal Engine. Okay? And actually, there's a good reason they called it branch instead of if-then, because in low-level programming, it is actually called branch, not if-then. Okay, and those of you who, where are my future CS majors or minors? right? When you guys take CS241 in the fall, you're going to learn all about branching. Or not this fall, but maybe next fall. It's going to be awesome. Or not, right? Okay, so we need to do a branch. And so we need to connect this, the execution node. Right? Okay, so true means what here? Right. True means that the dude we're currently looking at was weaker than our temp guy. So what should we do to our temp health and our temp enemy? Set them to the current item, right? So update them, basically. Okay? So I need to set the reference to, so I need a temp health set, and I need a temp enemy set. Okay? All right, so doesn't matter which order we do this in. What is our temp health? Well, it's this guy's health, right? And let me, oops. Oh, that's not what I wanted. I wanted it here. I'm just trying to clean up the wires a little bit. Well, whatever, you guys get the idea, right? Okay, and then, so set the temp health, and then what's the temp enemy need to get set to? The current target that we're looking at, which is this dude. So I'm going to drag, this is where it starts to get a little messy. I'm going to zoom out a little bit, and then I need to take this guy all the way over here. And then I'll do that. Damn it. Shit. Okay, good. All right, so set temp health and set temp enemy. Okay, good. All right, now what about if this condition is false? That means the thing we're looking at is not weaker than what we've already hit. So don't do anything. It's already been set. Just move on to the next item in the array. Okay? So in this case, there will be nothing coming off of the false. There's nothing to do. Okay, does it make sense why there's nothing to do? Because we've already previously set the temp health and temp enemy on the last step. Okay, does that make sense? We know. Okay. So, there's only one thing left to do, which is, oh, we're still not there yet. You really want to shoot at things, don't you? Yeah. Okay. What we need to do is go back to the loop, because what happens when the loop is finished? Then we need to, are we done with the function? Yeah, we need to return the weakest item, the reference to it, okay? And that's where this return node comes in. Okay, so this guy needs to go here, and I need to return who is my weakest enemy. It's whatever the temp enemy variable is. Okay, so the flow control here is we come to the loop. Is this the first thing in the loop or not? If it is, set the temp health and temp variable. If it's not, compare the item's health and to the current temp health. If it's weaker, update it. If not, don't do anything. Move on to the next item in the loop. Okay? When the loop is complete, then what? We've looked at all the dudes in the array, and so we're finished. And who's the weakest thing? whatever the current value of temp enemy is, we need to output that back to whatever's calling the function. Okay, does that make sense? Okay, good. So we got our function. And then we'll test it and make sure it actually works. Okay, so got my function, save. Okay, now, who is going to use this function? The tower. Okay, so let me go to tower A. And right now, tower A doesn't have anything in it, in its viewport, right? So let me add a component that's just a cylinder. That'll be sort of like the body of the tower. Okay, whatever. And then what else do we need? We need a collision volume, and I'll just use a spherical one for simplicity. If I could find it. Okay, am I just blind, guys? Rendering, physics, paper, navigation, lights, gameplay, field, chaos. Oh, here we go, sphere collision. Okay, and I'll just call it range sphere or whatever. All right, now, I'm going to put this thing oriented at the top of the sphere, or sorry, the top of the tower. Okay, and then its radius is pretty small right now, so let me make it bigger, and I'll just make it 250, whatever, right? I'm just making up a number at this point. Okay, so I need to go into the event graph for this thing, right? And the actor of begin overlap, okay? We actually are not going to use that here. We could, but
Isn't there an overlap for the collision sphere?
there is, right? Okay, now the reason I'm not going to necessarily use that right this instant is because when does the event overlap, begin overlap fire?
As soon as it overlaps
Okay, as soon as an actor comes into the volume, right? But what happens if it's already been in the volume and it's still in the volume? Does event overlap, begin overlap trigger? No, because it's already been triggered. It's only triggered the instant you come into the volume, not continually as you stay in the volume. Okay, does that make sense? The distinction. But we want to be able to shoot at the thing continuously, right? So we need to have the list of everybody that's colliding with the sphere, or that's inside the sphere, all the time, right? So what I'm going to do is not use these guys, but rather use the event tick, okay? So the way the engine works is every actor, there's a tick rate, okay? And we can set the tick rate to be slow, like once a second, or 10 times a second, which for a machine gun would make sense, okay? Just for demonstration's sake, I'll set it to once per second. Okay, is that all right? Okay, so let me do event begin play. On begin play, what do I want to do? I want to set the tick rate set actor tick interval. Okay, target self because I'm doing this for the tower. And let me just, for right this instant, I'm going to hard code it to, not 10, but 1. Okay, that's in seconds. So what this will do is that our actor will tick once per second, and that's it. Okay? Then, on the event tick, what I can do is I can say get all the things that are overlapping the trigger volume, and then pass that to the function, to determine who's weakest, and then the shooting part would happen after that. Okay, does that make sense? We first have to identify the target before we can shoot. Usually it's a good idea, right? Keep your weapon pointed down range. Keep your finger out of the trigger well until you're ready to fire. Do not point it at a target unless you're ready to shoot that target. Okay, this is like firearms training 101. Yeah? Yeah, this is what happens when your father's a Marine. You learn how to handle weapons. So, anyway. Okay, so we need to first get the list of all targets, all potential targets, okay? And so we want to get everything that's overlapping our range sphere, right? So there's a function for this. Okay. Oops. Get overlapping actors. Okay. And we want target is primitive component, that version of it. Because what component do we care whether or not we're overlapping? If this will. Which one do we care about? The range sphere, right? As opposed to the cylinder or whatever, right? Because the cylinder is to make the thing look cool. What I care about is if you're overlapping the sphere. I don't care if you're overlapping the cylinder. Okay, good? Well, and what comes out of this? A list of actor references, an array. Well, that's perfect. Because what are we then going to pipe that into? A function, right? The function get weakest. Okay. And then the tick will go over here. And now, there's one last little detail here. Class filter. If I don't set this, then what is going to get put in my list or my array? Other towers, conceivably. Any other actor of any other class that's overlapping that sphere. Okay, but what do I care about? Only what's are overlapping that sphere? Enemies, okay? So if I don't set that filter, it will return all objects. But what do I want? I only want to know of things that are of enemy parent class, okay, which will catch all enemy children that are below that. Type A, type B, type C, etc. Okay? If, for example, I wanted to limit this to a specific type of enemy, I could. I would just pick that specific type. So, for example, if I had like a tower that only could shoot flying enemies, then I would pick sort of the flying enemy parent class, whatever that looked like. Okay? And you can, by the way, have children of children, right? So, because like look there on the chalkboard, right? Towers are instances of tower class, which are instances of pawn, which are instances of actors. So your family tree, so to speak, can be as deep as you want it and as deep as you need it. Okay, good? All right. What's the problem with this, though? There is a potential problem. No, go ahead. Go ahead.
No, I was going to say if there's two enemies that are all equally weak, but you probably already win.
Yeah, the function will just pick the first one it encounters that's as the weakest, so that's not an issue. But what about if there's nothing overlapping that sphere? If there's nothing overlapping that sphere, do we need to call this get weakest function? It's going to kind of wig out if we try and hand it an array that has nothing in it, right? So why don't we first make sure that this array is not empty? Okay. How do I determine if an array is empty or not? Well, I'll use a branch, yes. Okay, so let me delete this for now. Okay, but how do I determine if an array is empty or not? What's a good way to think about this? Okay, we're going to have to use an equals, but what property of the array are we going to compare to 0? Right, an array is a list of items. Okay, how many elements it has. And what's the code word for that? The length of the array. So I need to get the length of this array and compare it to 0. Okay, so okay, so I need to get the length of the array, and this is an integer. Okay, and then I need to compare that to 0. So I could either use an equals or I could use a greater than. Let me use a greater than. Okay, if this length is greater than 0, what does that mean? There's something in the list that is an enemy, and therefore I can then pass that to the function. Oh, sorry. I should really clean this up a little bit. Actually, I'll just put this over here. Damn it. Okay. Okay, so if this condition is true, and we're going to do the true part of the branch, what are we doing? What does that mean? True happens here when what? Call the function. If it's false, what should we do? Nothing. Because there's nobody to shoot at, so we don't need to select a target if there are no targets. Okay? All right, so the true condition here, or the true statement, would be then call the function. Okay? And what do we need to pass to it? This array. Okay, and I'm sorry this is kind of messy, but do you guys get the idea? Yeah? So call the function, and that will return a weakest enemy. Okay? Does that make sense? Okay, so what would come after that, finally? The shooting stuff. Okay? We need to shoot at the enemy. And exactly how we choose to handle the shooting, there's a couple ways we could do that. Okay? So, all right, so let's pause for a moment. Let me make sure that we're okay with what we've got. Oh, and we need to test the function, and I'll show you how I'm going to test it. All right, so let me go back to sort of the code here, and let me compile and save it, and pause for any questions, preguntas, and or fragans. Okay, now Artie, I think when we were talking about this, I used equal, and so our stuff came off the false case rather than the true case, but whatever, right? 6 of one, half a dozen of the other. Okay, good? All right, so before we worry about the shooting part, let's make sure that the function actually works, right? And the quick and dirty way to test whether or not it works is this weakest enemy. Let me just print the name of the weakest enemy, okay? So I'm just going to do a janky print screen, or print string, excuse me, okay? And then the name of the enemy, I can't connect this to this, okay? But I can get its display name, right? So this says, okay, take the weakest enemy, get whatever its actual name is, and pipe that to print string so it'll print it on the console and we can see what we've got. Okay, make sense? And that's just to make sure that this actually is working correctly. Okay, so what do I need to do? I need to plop in a tower A, and I need to plop in a couple of enemies that are within, oh, and sorry, there's one other thing we need to do. I need to go into the enemy, and then the viewport. There's nothing in here, so the first thing I need to do is I need to actually add some sort of corporeal existence to the item, because otherwise there's nothing to check whether or not it's overlapping, right? So that my enemies actually have some, some stuff, okay? So I just put a sphere in there basically just to act as, damn it, what is with this mouse today? Okay, so I put in 2 enemies, and now what are their healths by default? They're both 100, right? That's over here, okay? So let me set one of them to a higher number or a lower number. Okay, so this enemy, I've got 2 enemies here, right? Enemy A and enemy A2, okay? Those are their display names, but notice if I hover over them, what does it do? You see where it says ID name, enemy A _8? Okay, so I don't know why they did this, but there are 2 different types of names. There's sort of the label and the actual ID name, okay? And when I first wrote this function and tested it, I was like, wait a minute, this doesn't make sense. I'm not getting the weakest thing out. It turns out I was. It was just I was mixing up which one I was looking at, right? Okay, so if I run this, what should get spit out? Enemy A2, okay? That's the label for the object, and that's this one right here. What about if I make this one weaker? What should be spit out? Enemy A. Okay, so does that make sense? So it works because it is correctly returning, the function is correctly returning the weakest enemy, right? That's currently within the sphere, and it's, you can't really tell, but it's doing it once per second because that's what I set the tick rate to. Okay, does that make sense? All right, so now what? We'd put shoot after the function returns the target, right? And so that target would be the item that we would shoot at in some sort of method. Okay, now, shooting. There are a couple ways to think about how we want to do that. Okay, what's one of them? We could spawn a tiny little sphere that fires in the direction of the target, and when it hits the target, like the bullet, if you will, could have its own little collision volume, and when it hits something, it casts to it, takes away some health, and then destroys itself. Okay? That means we need to create a bullet blueprint, and then the tower is going to need to spawn a bullet, and then make sure it is moving to the correct location of the enemy. Okay, now, this is where one thing could get a little complicated, which is, how fast should a bullet go? Pretty fast, right? Okay, but what happens if the bullet is going really slow, and for testing purposes, we'd want to make it really slow? I wouldn't be able to hit anything, okay? Because if you're moving, so let's say you're walking along the back wall, and I shoot this way, and you're over there now, by the time the bullet gets there, it's not going to hit anything, okay? Huh?
You would want to test if it was in place, right?
Well, at first I would test it with a non-moving target, yeah, because otherwise this is stupid, right? But then when you have a moving target, you have to worry a little bit that the rate at which the bullet is traveling needs to be super fast relative to the rate at which things are moving, okay? All right, that's not really a problem because we could set the bullet rate, and it would make sense that the bullet rate is going to be super fast in comparison to the movement of enemies, okay? But for testing purposes, we should make it slow at first and also make sure our enemies, like we haven't told our enemies anything about how to move yet, right? So there's still that, okay? Yeah, okay. Now what about different kinds of towers? Now this could present a problem if, what about if we had like a rocket tower that shoots a rocket that's going to go kind of slower than a bullet, right? We could either have some AI on the rocket where I give it a target and it's going to home in on that target, right? So it could steer itself. With a rocket, that makes sense. Doesn't with the bullet, right? We haven't invented magic bullets yet. Okay, so there's that. Or we could just make the rocket shoot, and whenever it intersects anything, it explodes, okay? And for explosion, quote unquote, what we could do is we could have, so like, well, let's go back to the bullet, for example. The bullet, I'd make a tiny sphere with a tiny collision sphere around it. And on begin event overlap, I would say, am I overlapping an enemy? Or sorry, an enemy? If so, cast to it, deduct from its health, and destroy myself. Done. Okay, and that way the instant the bullet hits something, but how are we checking whether it hits something? We're using a small little collision volume. Okay? For something like a rocket, what should the collision volume be? Probably a lot bigger. And in fact, there I'd actually want 2 collision volumes. Okay, and let me draw a picture and explain why. Okay, because probably what I'd want is something like this. That when an enemy is within the small collision volume, detonate, and then anything within the bigger collision volume gets damage applied to it. Okay, so does that kind of make sense? Like why I might want multiple of these things? Yeah? Okay, maybe I don't want that, right? I mean, I'm just kind of throwing out ideas here, right? But we could do that, right? Now, what about like, say, a shotgun tower? A shotgun tower would do maybe what? Yeah, shoot a spread of bullets, each of which are individually kind of weak, okay? Like, so maybe it spawns 100 things that each do 1 damage each, okay? And if you happen to be the really unlucky enemy that gets hit by all 100 of those, right, you're going to be having a bad day. But if it's kind of spread out, right, maybe 30 of them hit one enemy and 30 of them hit another, and then the other 30 don't hit anything at all, okay? We would also need to make some sort of mechanic, and this we could go back to the first-person shooter template to kind of learn a little bit from, because, right, what happens in the first-person shooter?
Oh, the gravity, like it moves.
Okay, it moved the blocks. We don't necessarily need that. But what else did we have in the first-person shooter? The gun actually fired little spheres. Okay, now they weren't actually so little. They were more like Nerf balls, right? But it applied physics to them to get them to move, okay? They didn't move particularly quickly, right? Because they were big, so we could just speed that up. But in terms of the actual getting something to shoot, spawning an actor, giving it sort of physics momentum and so on, right, we could sort of learn from the first-person shooter as one way to do that. Does that kind of make sense? Now, it's not the only way to do that, but it's certainly a way. Okay, so make sense? All right, so what's sort of the next sort of steps here, right? We've got to get the shooting mechanic figured out, okay? And that's going to be what I would suggest is at first rip off from the first-person shooter, right? There's no need to reinvent the wheel here. Okay. Second is we need to make these enemies move. That's actually not that hard because there is some simple AI that's real easy to throw in. Okay, there's a simple AI move to, which actually is how the movement of the player character works right now. Right? If I click, what it's doing is it's saying simple AI move to the clicked location, okay, which is not hard to do. You can look at the code and see what's going on. At some point, we're going to have to delete this player character so that we're just moving the camera about. There was a little bit of a wrinkle there because when we deleted the player character, the camera fell through the floor. Like it had gravity being applied to it, and obviously we don't want that. Yeah.
I was just wondering, like, I'm not sure if this will work at all, but remember like our code when they moved the floating islands around and stuff, like through like that stop and mission process? Do you think it would be possible if we could like do that with the enemies since they are going to go in a pathway because of like the tower defense thing, or would that not work?
Okay, so using the way we made the platforms move would not be what we'd want to do for the enemies. Okay, that said, and I don't think I've ever actually seen a tower defense game that has this, where the paths that the enemies trace through are themselves changing, right? So if we wanted to have moving blocks in the world, we could do it like we did in our code, but we don't want to use that for the enemies themselves, okay? Because our enemies need to go from one place to another, right? So they need to get spawned in one location, and if they get to a target location, then they need to deduct a point from you or something. That's different than a platform just moving back and forth, right? Yeah. Okay. What else? Okay, we still have to figure out how the hell to buy and build towers. Right? That's not going to be as hard as it sounds, but it's not going to be easy either. Okay? Because what we're going to have to do is we're going to have to create an actor that's like a spawnable position, and when you click on it, it spawns a tower at that location, right? And then makes it an unbuildable spot again, right? So we'll have to do something. It'll be mousy stuff. I need to figure out a little bit on the player controller here to modify the top-down player controller. But, right, so we got a little bit of work to do there. So I think we're probably the best place to keep working for right now is learn from the first-person shooter how to spawn a bullet, quote unquote, make a bullet blueprint object that gets spawned when it fires, which in this case would be every tick. You're going to spawn it and have it moving towards the target location. Okay. In the case of the gun in the first-person shooter, there was no target, but where did I shoot? Like, what was the direction that the bullet shot? Sort of where I, the player character, and my rifle or the thing is pointing, right? Okay, so I have a direction, namely which way I'm facing, okay? Now, what's the direction from a tower to an enemy? This is actually a little tricky at first. Well, it's going to, not necessarily. Okay, because if I'm a tower, I don't necessarily have a direction I'm pointing, right? But I have a spot that I'm at. The enemy has a spot that it's at. How do I get the direction from two vectors? You subtract them, okay? So let me just show you on the board here, right? So let me do this in 2 dimensions just for simplicity, right? Let's say I have 2 points, point A, which is at -1, -1, or 1, say, and point B, which is at 2, 2, okay? I need an arrow that goes from A 2b. Okay, that points in that direction. Okay, if I construct the vector c, which is b minus a, okay, then this will be b is 2, 2, a is negative 1, 1, and the way vector subtraction works is you do it coordinate by coordinate. So it's 2 minus negative 1. Right? And what's 2 minus 1? Okay? All right. What's this distance horizontally? 3 units. What's this distance vertically? 3, 1. Right? Okay, so the vector 3, 1 is this arrow that goes from A to B. Okay, so how would I do this in 3 dimensions? It's harder to draw the picture, but what's the idea? The exact same thing, right? Because how many coordinates are there in a 3-dimensional vector? 3, that's what 3-dimensional means, right? So it's just doing target. So if I want to go from a place to a target, I want to do target's position minus my current position, and that will point in the right direction. Okay, if you subtract the other way, what that'll do is it'll be the arrow from the target to you, which is actually 100, pointing backwards from what you want. Okay, all right, so does that kind of make sense? All right, so Thursday and probably Tuesday, let's plan to be over in the library working, okay? What I want you guys to get ready before Thursday, right, is go into the first-person shooter and kind of study how the shooting mechanic worked, okay? And figure out how you can start to adapt that to our thing here, okay? All right. So we'll quit for the day and have a good rest of your Tuesday. Okay? All right. And are we missing anybody other than Mr. Strode? All right, I'll deal with him later.